Every day, NASA receives more data from the James Webb Space Telescope, and more data opens up the possibility of new discoveries. There are many mysteries in the universe, but none has been as puzzling as the presence of impossible early galaxies. Webb has detected 15 strange galaxies that existed before the Big Bang, challenging our current understanding of the origin and evolution of the universe. How is this possible? What do these galaxies look like, and what does this mean for our future? Now, the most accepted explanation regarding the origin of the universe is the Big Bang theory. This theory states that space, time, matter, and energy were created when the cosmos began as a singularity, a tiny, dense, hot point that erupted and expanded quickly. It is estimated that the universe formed stars, galaxies, planets, and life approximately 13.8 billion years ago, after which it cooled down and became more structured. However, the Big Bang theory is not perfect. It has some unresolved problems such as the horizon problem, the flatness problem, and the singularity problem. These problems suggest that there might be something missing or wrong in our current model of the universe. Some scientists have proposed alternative or complementary theories, such as the multiverse theory, the inflationary theory, and the cyclic theory, to explain these problems. But none of these theories have been conclusively proven or disproven by observations, that is, until now. In 2021, NASA launched the James Webb Space Telescope, the most powerful and advanced space telescope ever built. Webb is designed to observe the universe in the infrared spectrum, which allows it to see through dust and gas and to peer deeper into the past than any other telescope. Webb's main goal is to study the first stars and galaxies that formed after the Big Bang and to search for signs of life on exoplanets. But Webb has also made some unexpected and shocking discoveries. As we know, the distant galaxy Z11, found by the Hubble telescope, held the record for being the most distant galaxy prior to the Webb telescope. It was only 400 million years old, or 3% of the universe's current age, when the Big Bang happened. It is part of the universe's first galaxy generation. Scientists have recently confirmed that 4 of the most distant galaxies are even older than the most distant galaxy observed by the Hubble telescope, shattering the previous record set by the Webb telescope's early observations. One of these galaxies, designated GZ13, was 325 million years after the Big Bang, making it the most distant galaxy yet detected. Because of the universe's expansion during the period that the light that just reached Webb left the galaxy, the distance between Earth and this most distant galaxy is currently estimated to be 33 billion light-years. However, scientists were taken aback when they examined the fresh observational data because they weren't expecting to see anything similar. Meanwhile, in 2023, Webb detected 15 strange galaxies that appeared to be older than the Big Bang itself. These galaxies were located in a region of the sky called the Hubble Ultra Deep Field, which is one of the most distant and faintest parts of the observable universe. Webb used its near-infrared camera and near-infrared spectrograph to measure the redshift of these galaxies, which is a measure of how much their light has been stretched by the expansion of the universe. The higher the redshift, the farther and older the galaxy is based on our present models. One of these galaxies has a redshift of around 17, which is impossible according to the standard Big Bang theory, which predicts that the first stars and galaxies formed about 200 million years after the Big Bang, and that nothing existed before the singularity. How could these galaxies be so old? What if the Big Bang never happened? Are we possibly looking into a parallel universe? And why has our science failed? Nobel laureate Dr. John C. Mather, the lead project scientist for the Webb telescope, put it in a nutshell at a press conference on current events: "We are looking further back in time than we could before, and we are really thrilled with this picture. We have been working on the story of how the galaxies grew. I told you we were going to see the first ones growing, and we saw some, and they were a big surprise. They were bigger, brighter, hotter than we expected, and some people said, well then, our whole story of the expanding universe might be wrong, and I think more likely our story of how the stars grew was wrong." The astronomers who made this discovery were baffled and puzzled by this paradox. They checked and rechecked their data, their instruments, and their calculations, but they could not find any errors or flaws. They also ruled out the possibility that these galaxies were actually closer and younger but had their light distorted or amplified by gravitational lensing, which is an effect that occurs when the gravity of a massive object bends the light of a distant object. They confirmed that there was no such object between Webb and these galaxies, and that their redshift was genuine and not an illusion. It's a galactic controversy that has astronomers around the world excited and puzzled. Not only is Webb finding galaxies forming 200 to 500 million years after the Big Bang, but also that they are bigger and brighter than astronomers expected. Even though James Webb is incredible, its information on the very oldest galaxies is not completely straightforward. Although it has provided us with breathtakingly beautiful views of neighboring galaxies, star clusters, and nebulae, its representations of the furthest off galaxies generally resemble fuzzy little dots. Although they certainly have some shape, spiral arms, and dust lanes aren't exactly what we're seeing here. Well, recent observations have shown that this galaxy was actually an imposter among these distant galaxies. The majority of the important data these photos provide comes from the light spectrum, which shows us how much light is reaching each color or wavelength. James Webb has two methods for analyzing a source's light. It can use filters that block all but a narrow range of colors, or it can take a spectrum and examine the brightness at each color by spreading out the light with a spectrograph, which functions something like a prism. The latter is basically a very low-resolution spectrum and is measured photometrically. In both situations, we compare the data to simulations of the spectrum we expect for a galaxy with those parameters in order to ascertain properties like the total mass of a galaxy's stars, their ages, or their chemical abundances. The galaxy's redshift, which indicates what point in the universe's history we're looking at by indicating how much the light has been stretched by cosmic expansion, is likewise calculated using these data. The galaxies we've seen with the highest redshift values, greater than 16, encounter an issue. Many of these galaxies appear to have too many stars or stars that are too old for the time in which they existed based on comparisons of model spectra. But there are a number of observational and theoretical ways in which we can be in error. From an observational perspective, photometric measurements are not always reliable. We have taken spectra of a few galaxies that appeared to be at high redshift, but were actually much closer. In an attempt to explain the shockingly bright, highly structured, and possibly quite massive galaxies existing so early in the timeline of the universe, a researcher has posited that the universe is roughly twice as old as previously believed. They pushed the age of the universe from 13.8 billion years old to roughly 26.7 billion years old. The discovery of these galaxies has profound implications for our understanding of the universe and our place in it. It also raises some philosophical and existential questions, such as what is the origin and purpose of the universe? Are we alone? Or are there other forms of life in other universes? And what will happen to us and our universe in the future? These questions are not easy to answer, and they require more research and observation. The astronomers who made this discovery are planning to use Webb and other telescopes to study these galaxies in more detail and to look for more evidence of other universes. They hope that by doing so, they will be able to unravel the mysteries of the cosmos and to learn more about our cosmic history and destiny. That's all we have for you today, and thanks for joining us on today's episode. This is Cosmos Prodigy.